Hello everyone, welcome to the new lesson, and in this lesson we'll continue the exploratory data analysis second phase, in which you will see how to make descriptive analysis for numeric variables. In the previous lessons, you have learned the techniques of frequencies analysis and its implementation on categorical variables to find significant insights. But what about numeric variables, right? Okay, we'll use the mean, median, mode, percentiles, standard deviations, variance, etc. measurements to find out significant insights for numeric variables. So let's see at first how to calculate the descriptives of the order value, cost, and refund, the three important numeric variables in our data set. So here you can see I write, give me a Python code for descriptive analysis for three specific numeric variables in a data frame. So what actually I am going to do? Just run the command. So here you can see ChatGPT again created a sample data, then we do not need it. You can see that in this particular line of code, it defines a variable and loaded the numeric variables for which it is going to make the descriptive analysis. And in its case, the numeric variables are age, salary, and experiences. And in the second line of code, which is our main code to calculate the descriptive analysis, here you can see that the numeric underscore columns are put within the data frame and third bracket to filter out these specific three numeric variables from the entire data frame it created, as you can see here, and within which it used the dot describe method, which is used to find the descriptive analysis such as mean, median, mode, maximum, minimum, etc. measures for numeric variables. You can just copy these two line of codes, go to Jupyter notebook and paste it here, and you have to make some revisions. At first, our first numeric variables is order value underscore euro. Our second variable is the cost of product sold, and the third variable name is refund. So we have changed them. Now we have to change the data frame we are using. Here we are using the final data frame. Everything looks fine. We have to copy the variable name and paste below it to find the numeric summary table, and you can see here is the boom. So at first you can see that we have information on 1009 instances of purchases, costs, and refunds. Secondly, you can see on average each purchase is about around 113,000 euro. The average cost to the business for each purchase is around 94,000 euro. The average amount refunded to the customers is approximately 49,000 euro. Now comes to the standard deviation. The numbers can vary from these averages by around 61,000 euro for purchases, 51,000 euro for costs, and 28,000 euro for refunds. This shows that there is some fluctuation in the values of the order value, cost, and refund respectively. The smallest purchase was about 15,000 euro, as you can see in the minimum sale for the order value euro section. The lowest cost incurred by the business for a purchase was approximately 12,000 euro. The smallest refund given to a customer was 1,009 euro. Now comes to the 25 percentile. 25% of the purchase had values under 65,000 euro. 25% of the cost were under 54,000 euro, and 25% of the refunds were less than 24,000 euro as per our dataset. However, the 50% indicating the median value or the median order value, median cost, and median refund, as per our analysis we can see that the median order value was around 105,000 euro and the median cost were around 86,000 euro and the median refunds were around 48,000 euro. Similar to 25%, we also get the 75 percentiles, and we can see 75% of the purchases or order values were under 151,000 euro, and we can see both the 75% for other tools such as cost and refund, which are around 126,000 euro and 74,000 euro respectively. Finally, come to the maximum value. We can see the largest purchase recorded was around 383,000 euro. The highest cost incurred for a single purchase was approximately 304,000 euro. The largest refund given to a customer was around 99,000 euro. This is how you can get a brief but useful insights for the numeric variables you have as per your subject matters. However, now we are going to see the distribution of these three numeric variables to get some precise insights again. So we'll go to ChatGPT. So here you can say, right, give me a Python code to plot the distribution of three numeric variables in one figure. That means we want to see the distribution in one figure so that we can make some comparison between them. Just run the command. Here you can see the long code for our data visualization. You can see that another Python library is loaded, which is Seaborn, and it is loaded as SNS. It is the Python library for advanced data visualization. This data visualization can be plotted with a little number of codes. Always be careful that whether in your Jupyter notebook the matplotlib.pyplot and Seaborn is installed. If not, then you have to install it by the way I have shown you. However, for now, let's copy this particular library's code to import it, and we'll use this to import the Seaborn in our Jupyter notebook. After that, you can see ChatGPT created the sample data. We do not need it, we can ignore it. And here you can see the lines of code to make the visualization or the histogram we wanted for our three variables in one row and three columns. At first, you can see the dot figure is used to define the sizes of our figure, and you can see the three blocks of code for each particular variable. In our case, we will use each particular blocks of code, one for order value, one for cost, and one for refund. At first, we will use this first block for our variable order value, but it is used for age as per ChatGPT's example. However, let's understand the codes. You can see that plt.subplot, and it is defined as 131 because we are using one row and three columns. Here you can see that ChatGPT defines you. It is indicating one row, three columns, first subplot, and that is why it is written as 131. And in the next, you can see dot hist plot is used from the Seaborn library. That is why the SN is written at first of it, and after within which you can see the variable is filtered out from the data frame, and KD is defined true. KD is the bell curve over the distribution of the histogram. So that is why it makes true, and it is required for some professional analysis. That is why we will remain it true. And after the plt.title is used to assign the title for this particular plot. Similarly, in the next block of code, it is used the dot subplots and 132. That means for the figure size, one row and three columns, this is our second subplot. And you can see the dot hist plot is used again, and within which the second numeric variable is filtered out from the data frame, and the title is set for this. And similarly, the 133 defines the third subplot of our one row and three columns figure, and dot hist plot from Seaborn is used for the third numeric variable, and the title is set as well. Finally, the plt.type layout is used to adjust the spacing between the three graphs, and dot show is used to show the results. However, we will copy. Now we have to make some revisions. At first, we have to revise the final df wherever we can see that df is written, because we are dealing with the final df, and we have to assign our variable names. First one is order underscore value underscore euro. We have to assign the title as order value distribution, and for the second block we'll use our second variable, which is cost, and here the title is cost distribution. And for the third block we will use our third variable, which is refund, and here it is refund distribution. Now run the code. So here you can see the distribution of our data. Lower this amount, you can see the cost distribution. You can see that most of the cost belong to the lower portion of the data, and the refund and the distribution of refund is approximately similar for all the values. However, now we will check various important descriptive measures through the use of box plot. So go to ChatGPT. So I write, give me a Python code to plot the box plot of three numeric variables in one figure. So here you can see the similar codes again, and you can see that at first it defines our figure size, it defines our number, our subplots, and it is similar for all the blocks of code. Just the difference is in this particular line of code in the three separate blocks of code, and which is the dot box plot. And this dot box plot method is used to plot the box plot for any numeric data, and within these brackets we have just defined the data, which is the values of a particular numeric variables only, and the rest are similar as we have described for our previous code of histogram. So just copy the codes, paste it to a new cell, copy the rest, and again you have to revise the df to final underscore df wherever you can see it, and definitely you have to change the variable's name for each block. Here you can see order value, euro, cost, and refund. Definitely you have to change the title. For the second block we will provide the cost title, and for the third we will see the refund box plot. So run the code. Here you can see the box plots. Okay, let's understand the box plots now. So here you can see the box plots of cost. The box plots define so many measures of descriptive analysis. You can see a middle line here. This particular middle lines is representing the median values of the data. So median is the value in the middle of the data. If you distribute or arrange the data from lower to higher or higher to lower order, this particular value is not affected by outliers. So it is important to include in the descriptive measures. You can see the median cost is approximately around 80 to 85,000 euro. The upper line of the median cost, you can see it is the 75 percentile. 75 percentile defines that the percentage of the data that is lower than a particular value. You can see the particular line indicating the 125,000 as a cost, and we can say 75% of the refund is below or lower than 125,000 euro. In the lower line or the axis of the box after the median line, you can see here it is the 25 percentile that defines the number of percentage that is lower than a particular value, and the number of data under 25% that is lower than a particular value. Here the particular line indicating nearly 50,000 euro. So we can say 25% of refund is under 50,000 euro. This particular line, which is at the last of this box plot, this particular line at the last, you can see, is indicating the minimum threshold for a cost, for a possible cost, and you can see the minimum threshold is under 50,000 euro, and this particular line indicates the maximum threshold for any possible cost, which is between 200,000 and 250,000 euro. And at the above the line, you can see some points which are indicating as outliers as per the calculation of statistics or statistical calculation, and these particular outliers are considered as a culprit of the normal distribution. However, you will know more about them while dealing with distribution in the data pre-processing part, which is the must requirement before implementing any machine learning or data science model. That's all. Thank you.